Hey, what's up, everyone? This is going to be a video covering congruence transformations, more in particular, translations. So, first we have the definition. Congruence transformation, also called a rigid transformation or isometry, is an operation that moves or changes the position of a figure, but preserves congruency. Now, that's a very fancy way of basically just saying that the shape itself, the image on the graph, does not actually change in terms of its features, only its position changes. Just like if I move something on my desk, such as my pen, it is still my pen. Nothing has changed about it, just where it's located. That's what a congruence transformation is. So for one, you have a transformation that moves all points a given distance in the same direction, can be left, right, and or up and down. So this is a translation. Which is mainly what we're going to focus on today. And you see an example right here. From the black triangle to the blue triangle, we went 3 left and up 2. To get that rule, you can just compare, like, for example, A and A prime, and try to get from A to A prime, and you'll end up going left 3 and up 2. Example 2, you have a transformation that creates a mirror image of points over some line of reflection. Well, this itself is a reflection. Okay, if I could, if it wasn't on the laptop, but if this graph was a piece of paper, I could fold it over this line of reflection that's drawn right here. Okay, and if I folded this graph, that paper, over that line, the triangles would overlap or run over each other. They would just fold right on top of each other. 3 is rotation. It's a transformation that moves points about a fixed point called the center of rotation. Rotations are expressed in terms of angle degrees. For example, rotation 90 degrees, 180, 270, etc., and can be clockwise or counterclockwise, with an example to the right here. 2 more definitions here. We have the blank is the figure before a transformation. This is very cleverly named pre-image. This is a pre-image. Then again, very cleverly, the image is the figure after a transformation. So you got pre-image and image. Then it says we often use a, and then it looks like an apostrophe. In math, we just call this prime. It's a prime symbol to indicate the image. So most of the times in math, prime being on something just indicates some type of change from initial position. Okay. Okay. And now we're here. This should be page 4 of your notes for my class. So to blank and or blank slide a figure. This is to vertically, I'm going to have to abbreviate here, vertically and or horizontally slide a figure. This is loosely the definition of a translation. And then each point of a figure is moved the same number of units and in the same direction. So math, itself is a language. And just like any language, we have a certain notation to express this transformation. Even though in plain English we might say, hey, it went left 2 and up 4, we have to put that in a more formal mathematical sense, and that's exactly what coordinate notation is just translating from English to math. So the coordinate notation for a given translation is 2 units right and 1 unit down. So what that looks like is you have x, comma, y, that's an ordered pair, okay? And then the arrow indicates the transformation. And then after that, you have your rule. So in this case, we said 2 units right. So again, right is horizontal, which is always going to be grouped with x. And right is the positive direction, so x plus 2, comma, similarly for y minus 1. It says write the coordinate notation of the following translation. 4 units to the left and 2 units up. Well, again, 4 units left, so that's going to be grouped with the x, and left is the negative direction, so x minus 4, and we also have y plus 2. Right below that, we have pre-image and image are blank, corresponding angles are blank, corresponding sides are blank. So, again, the English word for what we're looking for here is congruent. Now, the math symbol for that is this. It is an equal sign with a tilde or just squiggly line above it. This indicates congruency in math, which essentially just means that something keeps its structure or form, which the shape we are talking about does. We've been talking about that a little bit. So let's look at example 1. Example 1, we have a rectangle, MATH are the vertices. In our rule, it looks like is x plus 4 comma y plus 2. So we're going to go to the right 4 and up 2. For every point, every single point on that shape is moving right 4, up 2. We only need to look at the vertices, though, to get the good picture. So for M, our point was negative 5 comma negative 3. So simply plug, though that's your x and y, plug it into the rule. So negative 5 plus 4. So let's get this ordered pair ready. Negative 5 plus 4 is negative 1, comma. And then our y coordinate's negative 3. Negative 3 plus 2 is negative 1. So negative 1, it's right here. We can put our m prime to indicate the change. Do the same thing for the rest of the ordered pair. So negative 2 comma negative 3. Negative 2 plus 4 is positive 2. And then we have negative 3 plus 2, negative 1. So 2, negative 1. Okay, and this is our A prime. T, we have negative 2 comma negative 5. So negative 2 plus 4, again, is 2. Sorry, I'm running out of room here. So that's for the T. So 2 comma, and then negative 5 plus 2 is negative 3. So 2, negative 3 is right here, and that's our T prime. For H prime, we'll plug it in H, so negative 5 comma negative 5. So negative 5 plus 4 is simply negative 1. And negative 5 plus 2, negative 3. So negative 1, negative 3, right there, H prime. Boom, that is our image. So again, just for the vocab, that purple rectangle is our pre-image. The one we drew is our image. Awesome. Example 2, I would like if you could do that on your own or attempt it on your own. We're going to go into example 3. So now we're working backwards. So given that point P prime is 3 comma 2, what is the pre-image point if its image was formed by the translation? And then it tells us x minus 3 comma y plus 4, or in English, just left 3 up 4. So if we're going backwards, well, backwards essentially means opposite, usually. So we can just kind of use that train of thought to say, okay, well, if now I have the image and I'm trying to get the pre-image. So before we had the pre-image and we're finding the image. Now, again, backwards. We're given the image, we need to find the pre-image. It still gives us the rule though. So that's great. So if our rule is x minus 3 and y plus 4, well then if we're going backwards, easy money. Instead of saying x minus 3, we're going to add that 3 to here, to that 3 right here. So that ends up giving us 6. Similarly for the y, since we're going backwards, right? If I went up 4, but I want to get back to my original position, well, I got to go down 4. So let's subtract 4 from 2. 2 minus 4 is negative 2. And that's it. Now, if you wanted to formally set this up, which is not necessary, but just to show it for maybe will make it more clear for someone. So I'm just going to rewrite our rule real quick here. Okay, so we went from sum xy into 2, our image is 3 comma 2, right? So if I want to find,
It's now 3 o'clock. If you are not with a coach, director, sponsor, or in tutorials with a teacher, you must now exit the building.
sorry about that. If I wanted to find the x and y, I can just set it up like this. 3 would equal x minus 3, and 2 would equal y plus 4. And you could solve for x and y. But I think that way is probably just much more confusing. I think it's easier just to think, well, hey, we're going backwards. So if I went left 3 to get somewhere, to go back to my original position, I'd need to go right 3. And that is it. Thank you, guys.